Yes, let's see what we can do today. Okay, guys, very good morning and very good evening or very good night or any time, that doesn't matter. That we would like to go through some kind of a problem very heavily found in that survival analysis. You know, in survival analysis, we're going to do the analysis about the survivability of any item, any component, electrical, electronic, mechanical, or chemical components. Their survivability is heavily discussed through this survival analysis. Anyhow, let's look at this problem. Okay, let's look at this one. Very easy one. Okay, I'm going to write here. Determine. Okay, I think you can see clearly. Determine the survival function. The survival function. Okay, the function. I prefer to use a like abbreviation down the road for function. Look at my abbreviation. FU. Right? Subscript, superscript, n underscore function. The survival function for survival random variable survival random variable with hazard. With down the road, even with, I can write like this, with hazard function. Now I can use the abbreviation function given by hx 2x over 1 plus x squared. Is the part. So determine the survival function. Survival function has not been given. They have given just the hazard function only. With the hazard function, we have to jump into the survival function. Okay, that's what they are planning to do. Okay, then have a look at it. Taking 2 minutes. Okay. Okay, how to get this done? How do you get this done? Okay, in order to get this done, okay, let's go to the basics. Okay, let's go ahead and use the formula that we really need to calculate the survival function from the hazard function, where x is the time that particular component has survived. Okay, the time. Okay, let's go to hx. Hx has been given 2x, okay, 1 plus x squared. And this is I'm going to write this down. Okay. Now, how do you get the survival function? This is a hazard function. It's a hazard function. Hazard function of that particular random variable x. Okay. And I'm looking for survival function. Function of x. You get that? Let's get the formula. Survival function is denoted by Sx. It has been given by e to the power of integration, or you can say minus hx. And that means where capital Hx means cumulative. And then I can see n dot negative as a function. The function. Cumulative as a function. That's the cumulative as a function. So how do you get the cumulative as a function? We don't have a cumulative as a function. We have a asset function. So you know how do you convert that into cumulative asset function can be easily obtained from the Hasse function. So therefore, right? Therefore, this is my left. Okay, this is the symbol for therefore. 3 dots. Okay, we can use that one too. Down the road. So 3 dots at the vertices of a equal triangle. Okay, equal triangle. So that's a notation, mathematical notation. Therefore, Sx is nothing but e to the minus integration of this is nothing but right here integration of hx dx over x domain 0 to x is I'm going to put over there x. I can put over here t dummy variable. I can put a dummy variable. You can make it clear. Up to that point because it's a function of x, up to that point. So I can make a dummy variable. So your limit's gonna go from 0 to x h t dt. So therefore, you can get that one and plug in into here ht. If you want, you can play over there, or you can play here and plug in over there. Either way, it doesn't matter. Okay. Now, this is going from 0 to x. But we know that, we know that hx is nothing but, you can remember 2x over 1 plus x. I don't need the hx to plug in. Therefore, you can say, therefore, you can convert this into ht. Okay? ht is 2t over 1 plus x. See, arbitrarily you can change the variable. Okay, doesn't matter. Which letter that you're going to utilize. It doesn't matter which letter you're going to utilize. Okay, whether it's t or x. The way that is set up. If you want, you can integrate here and let's plug in over there, or just play over there. Let's plug in now. Let's play it over here. Let's integrate this. 0 to x ht dt. Let's do the same thing on this. 2t 1 plus with respect to this component has to go there later. Okay, I'm building up part by part. So how do you integrate this one? How do you integrate? Very easy. Now you have to go to the integral techniques or integration techniques. In integration techniques, you can look into the thing. This is a numerator, denominator. You can look into the denominator and see whether its derivative is going to be on the top. If it's the case, you can write this one with the ln, or you can use the u substitution. There are several ways you can get this one. Okay, there are several ways you can get this one. Several ways. Okay, several ways. So I'm going to go ahead and look for this denominator's derivative. Let's say derivative of this type, derivative with respect to to t. With respect to, we're going to write this as WR dot t. Okay. With respect to t, which is what? 0 plus 2t, which is 2t. Is 2t. This, yeah, you can see. Do you have that one on the page? 2t. Yes, it's over there. If that's the case, I'm going to still write here. Okay, for your convenience, I'm right here. Therefore, integral 0 to x ht dt is nothing but we can say simply by integration, since you have the derivative of the denominator is same as the numerator, you can say ln absolute the denominator, and then you're going to plug in the limits 0 to x. That's the integration of this thing. Erase this thing. Erase this thing. Then we can see we saw that derivative of the denominator is same as the numerator. By any chance you have a t only here, you can make the adjustment only with the numbers, not with the letters, not with the variables. You know, the letters represent variables. Okay, letters represent variables. So you have to make sure you're not going to do any adjustment to that. And by any chance, if you don't have a 2 over here, you have something like this 1 plus t squared on the t. You can just put t 2 over here and then divide by half to make it the way that how we want. Okay. Okay. You don't have, if you want, you can use a u substitution. You can call this one u, and then take the du and then do the instead of working with t, you can work with u, and then you can plug in. That's the same thing. But this is what. Okay. I'm going to erase this one. You have plenty of time to do this one. Okay. Now let's go ahead and plug in the value. Upper bound. ln 1 plus t will be replaced. Let's start. Minus ln 1 plus c. I plug in upper bound and then minus I plug in lower bound. So then let's simplify. ln 1 plus x squared minus absolute 1. ln 1 ln 1 is, you can remember the graph. Log graph is the ln, is the ln x something. This is x here. The graph is like this. This is 1 comma 0. Then ln x, that is ln 1 equals 0. ln 1. This is the ln x. Y equals 0. And it's going to go to when, as x goes to 0, y goes to negative infinity. Okay, we can remember this. When x goes to 0, y goes to negative infinity. As x goes to infinity, positive infinity, y also goes to positive infinity. And there's no negative side, so it's okay with the numbers. So therefore, this whole thing is 0. Therefore, we are left over ln 1 plus x squared. Now you have the answer for that integral. Okay. So I'm going to do this. Okay. Erase all of this. So then I'm going to plug in over here. Okay. This answer is this one and that ln1 plus x squared. So I'm going to put over here e to the minus ln 1 plus x squared, which is this. Now you can simplify further down. I can bring this negative to here. E ln 1 plus x squared negative minus x. Then what? E to the power of ln, e to the power of ln is 1. ln of e also 1. Can see. This is natural log. This is e. The natural log has been raised to the power of e. Then e here also you have another e here because the log has been written in terms. This is same as this one. E log e. That's why they get cancelled. So you can come up with 1. It will same thing. ln means you're taking log with respect to e of e means 1. So you know this. Okay, those properties. So therefore, in a similar fashion, I can say this going to be ln 1 plus x squared to the power of negative. This. Therefore, then we can adjust that one, and then we can write. Where's all the where's this thing? This one. Therefore, where's x? Therefore, see, you don't have to write plain English. Just use a mathematical notation. Just x. Okay. Just x is nothing but. I'm gonna bring this one right that one positive exponent. That means I'm gonna bring this one 1 plus x squared to 1. Geez. Which is this is 1 plus. This is the answer. They were looking for the survival function for given hazard function. Then you have to build in when looking into the connection. Okay? Connection. And if you go further down and then a little bit further down, how do you get the probability density function? Probability density function. Now we are looking for find the probability density function. Probability of the PVK, we're going to say PROB, variation density function. Excuse me, we know that notation that as of now abbreviation, the abbreviation we can utilize function. So together, all this we can say PDF of x. Now we are looking for not the survival function, probability density function, which generated the survival. You know, we know that f of x, that's the probability density function means f of x. Okay. PDF of x, f of x given by negative is of x. Negative is x. Okay. take the survival function and take the derivative of that one to the negative. Or you can write like this way, negative d sx over dx. Since you know, since you know what the survival function already, we already got the survival function 1 over 1 plus x squared. You take the derivative of that particular guy with respect to x and then multiply by negative. And you can easily take the derivative. How do you take the derivative of this guy? See, it's easy. One shot, no? You can use the chain rule. You can go and take the derivative of this guy with respect to this thing, whole thing, 1 over x. See? If you have a 1 over capital X, if you are looking for its derivative, see? It's another way of writing that one derivative. The notation first derivative can be minus 1 over x squared. You know, the chain rule, you have a 1 here. It's going to go to the top. See? How do you get that one? You have 1 here. You're going to write this one this way. X to the negative 1 and its derivative. Now you use the power rule here. Okay? Negative 1 x negative 1 negative. That's how you get the derivative. Negative x to the negative 2. Then you're going to make it positive negative. That's how you get it. In a similar fashion, let's do this one over here. But this time, if I'm going to go ahead and look at the denominator, you don't have x, you have 1 plus x squared. So you're going to do the derivative first with respect to 1 plus x squared. And the 1 plus x squared should be differentiated with respect to x later. Okay. So we go here. I have a minus. I'm going to get another minus from here. 1 over 1 plus 4 x squared to the power of 2 times. You go inside and with chain rule, you take the derivative of inside, which is 0 plus x. 0 plus 2x. Okay. So therefore, f of x is nothing but negative, positive. That becomes 2x over 1 plus x squared to the second. You got to see it. Come backward. We've been given in the very beginning that Hassett function. With the aid of Hassett function, what we did was we derived survival function. With the aid of survival function, we derive probability density function. Okay, and I'm going to continue this part. Then this for you to see the final result very clearly. Okay, so if we summarize what we did over here, you can easily say we know f of x, probability density function of x, probability density function, which is 2x over 1 plus x squared to the power of square. Okay. We know survival function. Survival function. The shortened form is SF of x. Abbreviation for that one, survival function is the same with the probability function. S6. We found that one S6. 1 over 1 plus 6. So, and asset function. Asset function HF of x, which is given in the very beginning. I'm going to write that one along with this one. 2x only. 1 plus. So 1 plus. These are the ones that you've been given this guy. You derive this one and as well as this one. So I hope this is gonna be very helpful for you, like your homework or to get idea about that one. If you're pursuing PhD or master's or even a bachelor's, and how to in such a problem, how to with the aid of the asset function, how to derive survival function and the probability density function of the given random plus survival random variable x. I hope that we can meet you guys again in this kind of a video and then build up the more knowledge. Thank you very much for watching this. Okay, thank you so much.